Hi, everyone, and welcome to the IIoT World Energy Day, Readiness Built on Earned Trust Against the Surge of Industrial Cyber Attacks. My name is Chris Blavel. I'm with Fortinet, Director of Operational Technology, and thank you for coming to our webinar today. So if you have any questions as we're going through, please make sure to put them into the chat, and please let us know where you're from, what industry that you're from, whether you're generation, transmission, distribution, or something similar. Just a reminder that this presentation, a recording, will be available afterwards. And so, gentlemen, we'll get started. One of the things that we're seeing within electrical utilities is the adoption of digital transformation. We're doing that for a variety of reasons, mostly to meet our customer requirements. And so, what has that had on your industrial cybersecurity? NERC is obviously a big factor, but really, Dave, what has that had an impact on as far as managing your cybersecurity programs?
Yeah, thanks, Chris. I think just looking at the titles of even the sessions from today and where the themes really center, we're starting to see a lot of exciting new technology, a lot of good reason for, I think, utilities that generally have been conservative and very consistent and stable, now need to look towards these new technologies, distributed energy resource, what have you. And I think what it drives is obviously these new pressures for cybersecurity. We no longer have as much of a centralized grid, certainly with devices being spread out, being at different sites, perhaps not at utility-owned sites, a lot of shared connectivity, a lot of different topologies. I think that rate of change drives a significant impact, because the way that cybersecurity has been managed in the past is not the way it can be managed going forward. And so I think that everything that comes along with the change, people, process, technology, really kind of changes the priorities and kind of can certainly, I'm not going to say it takes the focus off NERC SIP or anything like that, but it certainly extends all the considerations a utility must make when it comes to securing their environment.
Yeah, absolutely. Paul?
Yeah, I like to touch what David said, that the utilities are changing. They are moving away from a centralized system to a distributed system. That means in one direction, the power will be generated at so many places at the edge of the grid, and that power is flowing back to the grid. So now it is going from a unidirectional system to a bidirectional system. In this new system, that the cybersecurity becomes a big challenge, because now some of the assets you don't control, and you have to look from not from the operation perspective, what are your devices doing, but what are the things which are connected to the grid are doing, how much renewables are coming back, how much storage is connected. So all those things, and in order to take all that information and make a decision, so what happens, that integrity of the electrical network need to be maintained along with the integrity of the other devices. So in this new paradigm, the substations kind of become a critical component. Now they will be basically looking at end-to-end decision-making process there. And what leads to is the digitalization of substations. And we're going to get away from that old concept of putting a custom fixed function legacy hardware there, which has limited or no security in it, to more towards the standardized infrastructure and build a multi-layer security strategy around it, from the hardware to the firewalls to basically protecting each application, monitoring the traffic between the applications, because as we know, there is no silver bullet for the security. We need to have that multi-layer approach. And I think that's what kind of a digitalization will drive in the utility industry, and whether it is in generation or transmission or distribution. And I think the biggest challenge will be in the distribution side, whereas generation and transmission traditional, they are very structured, but the distribution will become this very unstructured or distributed system, and we will require the full digital transformation with security in mind.
Yeah, thank you, Prithpal. Landon, do you have any thoughts?
I'm going to back up a few years. So I come from a utility where serial was king. And so just the simple fact that a lot of our utilities are transforming from a serial world to an IP world is making a huge difference, right? So before this, you were pretty much out of luck if you were hoping to secure anything with serial. You just had some obscurity to go along with. Now that things are moving to IP, you've got the ability to encrypt links. You've got the ability to begin looking at the traffic a whole lot better. And frankly, there are a lot of commercial off-the-shelf products that can be used with some type of modification, or at least it's made it to where vendors are more interested in supporting utilities and interacting with utilities because their product looks like something a utility could use. So I'm going to say something very simple. IP has made a huge difference. Obviously, it has made things possibly more reachable, but there are ways to secure things now that really we didn't have other than a true traditional air gap.
Yes, Landon, I'd like to add one thing is that I think in my discussion that the substation engineers need to become partial IT engineers. They need
Absolutely.
to learn the IT technologies. It is not that going to be IT separate versus OT. No, substation engineers will become the IT engineers. In the workforce, the technicians, everybody need to be trained on the IT technology.
Agreed.
And so as we move to IP, there's obviously something that comes along with that, right? And that's increased exposure, right? And so a question for Prithpal, how would you characterize the impact of a breach on the energy sector? I know energy sector is a very broad category. As we look at how all these systems interconnect, pipelines are powered by electrical utilities along their entire route. There are generating stations that are integral to operations of some of these very complex systems. And so what does that look like, both from the micro of the target, as well as the macro of the effect on the overall system?
Okay, I think let's look at like a two ways. First, look at what is the economic impact of the breach. If we look at just purely outages, which are caused by various reasons, I live in California, and the last data was it costs billions of dollars to California economy every year because of the outages. And if you take some breach to the next level, where breach affects at a bigger scale, the economic impact will be huge on our GDP, on our commerce, with the electrification of our transportation sector is happening, on the mobility of the people. So the consequences are huge if we look from the economic point of view. But if we go look into the next level, that basically the technology and operations point of view, so how these kind of things impact. I think we got to peel the onion a little bit. What is the current system which we have, which has pretty limited security built into it, but a wrapper around it. Okay? And so if somebody is able to go through that, the security wrapper, and after that everything is pretty open, okay, then basically they can do anything. They can shut down the power, Okay, they can put a malware into it, create the havoc on the system. So I think what we need to think about on the next side is that how to build the next generation systems to safeguard against these things and build that multi-layer security. And I think my view is that going towards the standardized products, a standardized hardware, a standardized software-based security is the way to future. Because if we build a standardized software-based security, then threats change. With the threats changing, we can deliver the next fix very quickly versus try to make it a hardware dependent, and which makes it very difficult to replace it. So I think that's what we need to go towards, is software defined security and using standardized tools off the shelf with some of the standards behind it, whether coming from the NIST and other organizations.
Yeah, great, thank you. Landon, one of the things that occurs to me is that there's the economic, there's the technical, there's also the trust aspect, right? What does a cybersecurity attack do to the trust of your ability to keep the lights on, to keep life-saving resource essentially in service?
So depending on the type of breach, obviously it can be catastrophic. In the world we live in, everything relies on electricity. The hospitals, police departments, airports, everything relies on electricity. Even if they have backups, they do rely on electricity for an extended outage. I will say this, many of us are equipped. We have plans, recovery plans, disaster recovery versus incident response plans that would allow us to detach from public networks, number one, and number two, to run blindly. We have already talked many times about how if we were breached, what we would do and how we would continue to provide electricity regardless of what's going on on the data side. We may have to man every substation. We may have to call back and forth. We're going to keep the lights on. We don't get to shut off the lights for anybody, right? So from a trust perspective, there are concerns, but I want to assure everybody we will do what we have to do to keep the lights on.
Yeah, great. Thank you. And so going a little bit more into the micro, what control systems are considered the greatest risk for compromise? There's a lot of control systems that maintain electrical grid. There's the SCADA systems that we use to send commands. There are protection systems that are constantly operating and waiting for a fault on that line. And so, Landon, what do you think is the greatest at-risk system in the electrical grid?
Traditionally, the focus of governments, of media, have been on larger utilities, generation and transmission entities, and those would supposedly yield the greatest single rewards for threat actors, right? But as Prathal was saying earlier, I think the distribution utilities are really, they've been able to fly below the regulatory radars for a long time. They have the least staff, they have the least funding for protecting their systems, implementing truly great cybersecurity programs. And like Prathal mentioned a while ago, we're becoming more distributed. There are devices everywhere that are capable of being compromised. So I still believe that the SCADA systems are probably the most vulnerable because a lot of them are indeed basic servers running on Windows systems. Hopefully they're current and patched, things like that, but really the distribution systems are not required to unless they meet certain criteria with NERC and SIP, things like that. So I would argue that distribution systems are probably at this time at most at risk.
Okay. And so, Dave, I'm curious, what your thoughts are, especially as we deal with an industry that has legacy equipment, will continue to have legacy equipment. Maybe we'll always have, some version of legacy equipment. What does that look like from what you're seeing with your customers?
I think it speaks to, again, sort of what Prithal referenced, is starting to employ a defense in depth strategy. And I think, again, Landon, that was spot on, that you need to maintain these different layers of resiliency, if you will. And some of that, at some point, it becomes remove the systems, go manual. And it's very easy to lose sight of that, I think, but that's important to keep kind of in the focus in business continuity plans and what have you. But really having an awareness of how everything works together. I think as we see, again, back to that rate of change and the pressures that that puts on our personnel, again, now you have individuals that need to support these systems that don't necessarily have a technology background or an IT background, yet some of that baseline needs to be there. So being able to gain an overall picture of the environment, how individual devices maybe impact each other and how everything works together, the better picture that can be painted, better chances of protecting it. And really, I think when it comes to kind of industrial cybersecurity, OT cybersecurity, we need to really focus on protection. Sometimes it's easy to we get stuck looking at ensuring we have proper detection in these environments. But if we can better protect these environments, better design security, and really ensure security as a design principle as we deploy new systems, yet realize we need to support the old, I think that sets us up for success, right?
So what are some of those challenges as we start to look at defending the networks, defending the devices? I know that something that's very important in designing electrical systems is resiliency, right? Contingency planning, things like that. And really in cybersecurity, we call that defense in depth, right? I have multiple overlapping technologies. If one fails, I can expect another one to catch an intrusion, an attack, etc. What are some of those systems that we are seeing within utilities, and how are they being deployed to provide that overlapping protection and that contingency planning? That was a question for you, Dave.
Yeah. Oh, okay. So yeah, I think looking at the network layer, certainly hesitant to use buzzwords or marketing or whatnot, but adopting zero trust principles, right? Really, truly based in kind of the core principles of zero trust, and implementing that where possible, and focusing on the network layer is important. I think as well, we're starting to see it more and more where we have software defined technologies, even from some of your automation vendors and core vendors in this space, where now they're moving things to more of a software defined nature. And I think that's very encouraging and good to see. I think there'd be a lot of potential in that. And again, it's really how do we give proper visibility and insight into all of this? How do we orchestrate it? Not necessarily automate or have it fully autonomous or what have you, but how do we create an orchestration layer in this environment such that we can easily respond to an incident or respond to an operating condition that's unexpected or what have you?
Great. Prithpal, what are your thoughts there?
Yeah, so thank you, Chris and Dave. So I think I'll look at kind of two ways to it. What we have there, it is there. Okay, the old legacy equipment, nothing we can do about it other than putting a wrapper around them and trying to safeguard them. But I think we need to think behind what direction we are going. And I think that there are a couple of kind of fundamental decisions which we need to make. And I think a lot of utilities are looking at it and working on it, is to first embrace the IEC 61850 standard for substations. Okay, that's the key. We need to go from the old system, define the station bus, define the process bus clearly. Once we have those two systems defined, now we can start thinking of the holistic security to it. I mean, going back to it, when we build this system on a standardized hardware, in all those applications, whether we are on a station bus, a simple RTU or HMI or synchrophaser, or name it, all those get digitalized. But in that system, now we can secure the hardware, we can secure each application, and with the firewalls, would monitor all the communication, and also we monitor the traffic. We do look at the log analysis, going back to basically embracing the security technology into a active monitoring. We cannot be that in the mode of that, or something happens, we'll do it. It needs to be actively monitored. So that's what we can do on the station bus side. And then we go on the process bus side. We do the same thing for protection and control, but we add one more layer to it, because we go to the station, into the process bus, we're going to add merging units. The merging units are collecting the sample values from the breakers, from all the electrical assets. Okay. How do we encrypt the data, the packet, when it basically gets converted, picked from that hardware device, analog to digital conversion, encrypt that packet, sent to the main system, okay, and then there that packet get processed. Because I see what vulnerability will come when we start fixing these things. The bad actors will go after, how can I manipulate the data and feed the wrong data to the system, and then system will make the decisions on it. And I think that's a kind of holistic overview we need to give to this problem, versus trying to kind of pick and choose and fix one thing here or there.
Thank you, Prithpal. Very, very good technical answer. I know that 61850 has been a long time coming as far as implementing the digital substation. Landon, I'm curious, is 61850 something that you see your utility implementing, neighboring utilities? Is that a guiding principle? Is it, the 61850 tends to really focus on the substation versus other aspects of managing a utility. And so I'm curious how that affects what you do and what you're seeing your neighboring utilities do.
So Chris, I wasn't expecting a question on 61850 here. In all honesty, we have avoided 61850. We haven't avoided IP at all, but we have avoided 61850. The complexity of it, we have talked about using it for some automation of monitoring certain devices catching a fault or something like that, triggering automation. But we have chosen so far not to go that route. Doesn't mean we won't someday. A lot of that had to do with the development. Early on stages of 61850 development was pretty catastrophic. A lot of entities played with it and ran away from it after they had so much trouble getting different companies to integrate kindly with each other and play nicely with each other. So there may be a day we come back to that. Right now, we still do a lot of serial in the substation. We still do a lot of DNP with IP, and we protect and protect and protect.
How does encryption play a part in your communications? Do you use it within the substation? Do you use it between substations and your control centers?
Once you're in the substation, there's no reason to encrypt inside the device, inside the building. I mean, if you're physically there to be able to get it,
it's a physical security problem,
right? Yeah. But we do encrypt everywhere else.
Okay. And how does that change what you're able to use as far as your WAN path links? There's history. There's a history of, I have a T1 line that serves a single 9600 baud serial connection, right? And maybe that's not needed anymore, and that expense isn't needed anymore.
Right. I will say NES has done a fabulous job over the last 20 to 30 years. We have every bit of our stuff on private fiber, private dark fiber. And
Wow.
so we run encrypted IP everywhere.
Mhm.
I know we're probably a unicorn. We're very fortunate in that sense. But we're looking, even though some of our radio stuff that reaches out to field devices, what we call DA or distribution automation devices, that stuff is over radio, and we are having to look pretty closely at the different vendors who provide encryption built into their radio systems. That has been a little bit more of a challenge than our substation stuff. So we do what isn't encrypted. Some of those things right now is on its way.
Okay.
And that goes back to that whole IP concept. Being able to use IP opens up the doors for all sorts of things. Monitoring encrypted traffic even, right?
Mhm.
And using not some strange brand of something. It's using truly commercial off-the-shelf solutions like the encryption that is provided in those devices. So particularly network devices.
Yeah, that makes a lot of sense. And one of the other things that Paul mentioned was some of the automation that can go along with that. How has automation changed what you're able to do in protecting your system from cyber attacks?
So let me start off with automation is a very, very sensitive topic when you get to particularly electric utilities. We don't like the idea of things happening on their own. That's from a safety perspective, from a resiliency, reliability. We just don't like things just happening. So, but with that said,
when you say that, Landon, you're talking about fully automated response, right?
Correct.
Yeah.
Right. And that's what Paul mentioned a while ago. I think he's right on target. It's not a matter of shutting off all types of things. What we can't handle is a false positive, right? Your lights, you want your lights on. It's our job to keep them on, and false positives don't allow for that. So there are ways to implement these systems that limit your exposure. For instance, interrogating devices that connect to your network and only allowing them to do certain things. If you have some type of behavioral monitoring software that doesn't necessarily shut down its complete possible traffic, but it limits it to only certain ports and certain devices so that you aren't necessarily passing HTTP traffic. You've blocked off anything that was a standard typical threat vector, and you're only allowing it to do what it has to do to maintain the grid.
Okay, thank you. Dave, what are you seeing with some of your customers, how they're using machine learning, other types of automation, and again, not necessarily full automation end to end, but maybe some kind of person in the middle automation where you are alerted to an anomaly, you are given a choice of recommendations, and then we automate that response, right? We allow a grid operator to determine what the response is, just like in any other part of their SCADA system, their advanced distribution management system. What are some of the things that you're seeing?
Well, again, I think you said it quite clearly, is really focusing on decision support systems, right? And looking kind of holistically at it, using analytics to analyze the past to inform the future, right? And really being able to we're consuming more and more data, being able to really warehouse and do analytics on that data, I think has opened up some new realms. But again, I think like Landon said, it's really to temper it and to focus on decision support, to ensuring that you're equipping your personnel with data that you can guarantee the integrity of, and really focusing on that presentment. Because I think the flip side is we need to embrace automation. It does offer a lot to us. It really can build a dynamic grid. I think it will be needed with more distributed energy resource and what have you. But again, how can we create an orchestration layer to really just help people be able to operate efficiently, and avoid, if you think the efficiency is gained by not rolling trucks, I mean, it's significant. And so we really want to, I guess, pick and choose, if you will, where we implement this automation. Now, in terms of security automation, I think, again, it is, yes, back to really analyzing behavior, but I think it also speaks to the importance of being able to baseline the expected behavior, and investing in the ability to do that and have standardized. I guess it comes right back to our standardization, statements and whatnot. But the better baseline we can have, I think that the better, set up we are for automating certain functions, as long as we can kind of maintain safety, reliability, and productivity, right? So.
Yeah, Chris, I'd like to add one thing here, as they mentioned. I think with the data, what it will lead to is that basically a data-driven grid, and which will kind of build on the top of it a active grid management. And the active grid management will, I think, one part of it is that looking at security and threats and all those things system level actively. And on the other side is that looking the demand versus generation with large scale distributed energy resources to constantly basically adjusting it. And that all these things can be achieved through the data. And I think data will become the key. And as Dave mentioned, we got to make sure that integrity of the data is considered right from the beginning.
And so you talk about the data and how important that is. I think one of the things that Landon touched on before was, how do we verify or ensure the integrity of that data? Landon, you talked about how how you're using encryption to ensure that somebody can't basically do a man-in-the-middle attack and change the data. Prithpal, you might have mentioned something about that as well. And so, it occurs to me that when we're designing a control system, there's a lot of effort spent to ensure that we are getting data with integrity, right? That's what helps us, helps inform decision making. And if you have bad data, but high confidence in that data, some really bad decisions can be made. And when you get into cybersecurity, it's their goal to give you high confidence in bad information, right? And so how do we verify the integrity of the information that we're getting? And Prithpal, I'll kick this back to you. What methods can we use to deconflict data that is coming in and make sure that we're getting the same information from multiple sources, or that the data hasn't been compromised along the way, if we are truly doing data-driven decision making?
Yeah, so Chris, I think we're going to look into this concept that once we evolve into this new system of connectivity everywhere, we want to connect every asset. And I think with connectivity and security are kind of two sides basically of the same kind. They go hand in hand together. We need to have the security architecture built on the top of it, along with it. Once we have these two things combined together, and then we have all the next layer of metadata coming with it, so we have the history along with where it is coming. And I think combining all those three things, the origin of the data, along with the strong security on the top of it, along with the connectivity, then we can guarantee the reliability of the data. The second, I think, thing on the top, we need to learn to process the data at the edge. Okay, we cannot move this large scale data from the substations or other devices where it is generated. In place of moving the data to a central location, processing it, sending the decisions back, we need to bring those software which makes this decision close to where data is generated. And that takes away also those threats and challenges, because no, data is not transferring across multiple systems and opening for vulnerabilities. I think that is what kind of shift happening, and that lead to basically what we call that intelligent control systems, okay, where those systems will get better with time because they reside next to where the data is being generated. And as they crunch more and more data, they get smarter with time. And then those intelligent control system will make, I think, better decision or autonomous decision, and will have a higher level of confidence in them going forward. So that's how I see kind of this whole thing evolving.
So, Prithpal, I think we've had data or devices generating data for easily the last 20 years. Just about every protection relay you've been able to buy has come with support for something like synchrophasers and the data, huge amount of data that is possible from that, right? You talk about processing it at the edge. What are some of the things that you have seen for processing at the edge, maybe at the substation or aggregations among substations that have led to increased reliability and security?
Yeah, thank you, Chris. I think what I see is that it is a journey. In one of the journey which we saw working with the utilities in my experience, yes, you're right, these old systems generate data, but they are all one device doing one thing. They don't share with the next device, what the next device, one IED is doing its own job. Data gets generated, but a very small amount of data gets out of it. Other just gets trashed right there. What utilities are thinking, some of them are working, is that how can we build the infrastructure especially in the substations, that where I can store years worth of data, and then I can basically start applying federated analytics. No, don't need to move the data between the substations or between locations. Using the federated analytics, data can reside where it is, and I can basically use it. And then you only send some of the limited set of data required by regulations to a central system for historian purposes storing it. And I think that's what we see. But how that evolution will be possible? First thing is that we need to eliminate that basically individual devices. We need to build a what I call it a micro data center in the substations, in where all those functions, the IED functions, whether it's a differential protection or a generation protection and distance protection, they get virtualized or software defined. And all the sample values coming from the different sources, they will be put into a single database. And now we can have analytic applications looking at it, the data, and basically they can do predictive maintenance right there. If I see these kind of signatures, what is happening to my breaker? Okay, so they can look at the data and report that, and also other kind of faults which current protection relays cannot detect because the way the algorithms are written. But using AI-based algorithms, we can analyze the data and see and extract more information out of it. What I call it getting better insight and faster decision-making capabilities.
Great, thank you. Landon, what are some of the things that you're seeing being put to use in, as we gather all this data, as we really gain some kind of actionable intelligence? I've seen some examples from the vendors. What are you using on the ground that enables your security in your decision making?
First, let me back up a little bit. I may be a little bit at odds with Prithpal on some of the pushing stuff to the edge. I have a little different perspective on not just security and data, but on personnel safety. And that's really, I think, a big difference that occurs in an IT data-driven world and an OT physical world. I have considerable concerns about pushing changes to things in the field based on what happens at the edge that doesn't necessarily look at the adjacent substation or the adjacent system. So I am still of the opinion that a great backhaul and a secure connection back to a location where I can make intelligent decisions and have, unfortunately at this stage in the world, a human interaction does mean a whole lot more to me than AI. There may be a day, there really may be a day when AI grows to the point that we can trust it to make field decisions. I don't see that yet. My linemen, I don't think they would go with that. And frankly, my operators would be very concerned about things happening on their own, right? So with that said, bringing data back is very important to being able to analyze data in a more holistic view, to take it and compare it to something else. One of the overarching themes of IT is CIA, right? Confidentiality, integrity, and availability. The OT world works a little different. 15 years ago, I was trying to explain it to someone. I said, really, it's not CIA, it's AIC. What you need from me is power. In order to do that, I have to have availability of those controls and data. That's foremost, so availability. Next is integrity. I really need my data to be correct. However, it's less important than availability because I have multiple sources of the same data, or at least something that I can add up. If I add up 5 breakers in a substation, that tells me what the low side is. If I have 4 of them reporting and 1 of them not, I look at the low side and I realize, wait a minute, there's something not adding up, and I have something to go by. If I look at data from one substation and compare it to the adjacent substation, I can get a picture for what's going on there. So integrity is important, but it's not as important as availability. And third piece, low on the list, frankly, is confidentiality. You can look at Google Earth and see my substations. There is no way I'm going to protect my power lines and my substations from your knowledge. Now, confidentiality kind of is coupled with protecting the data in transit. By encrypting data, I inherently gain confidentiality, but that's not my goal. My goal is to keep people out so that I have availability and the integrity, and later on have the confidentiality. Because I want that data to come back so that people, and eventually it may be AI, to look at a big view, not just of one substation, but of what's next to it, so that it can wisely determine how to route power and how to keep the man out there who's in the bucket truck safe.
Thank you. You know, going to that centralized data management, you know, as we look at the data that's coming back from all these devices now, which maybe used to be stuck in the substation, now that we have those backhauls, you know, what are you seeing in terms of your ability to better administer your grid?
Data is power, right? It is complicating the world, but it's allowing utilities like Splunk to become amazingly useful. Again, looking at commercial off-the-shelf products, things that we haven't been able to see, statistics we haven't been able to see, or at least haven't been able to aggregate and make any sense of them. We had the data, but it was spread out across all of the devices in the field. We're able to interrogate those devices, or at least listen into messages from those, and gain some pretty cool operational value. We know what our systems are doing better now than we ever did. We can, one thing we used to give only a certain list of data points back to our operators, because if they got any more, it would confuse them, and they had more important things to do than to look at the little values in something to know if a particular little piece of some device was starting to go bad. Well, now we can create automated alerts on hey, the current level in this laser is starting to go high, and we can predict problems or outages to telecom devices or things like that. So all of that data coming back from the enormous number of IP-based end devices is very good and very beneficial to any OT environment, regardless of whether we're talking oil, gas, manufacturing, things like that.
Are there?
Chris, I'd like to add one thing. I think
Yeah.
what I call it that what data brings to the utilities. First thing, greater visibility. The next thing is more refined insight, and gives the capabilities to make a decision faster. And take one example. If a utility has an infrared camera monitoring a transformer, as transformer is getting overloaded from load, it goes from green to yellow to red. And then they have a monitoring system on the transformer also. No utility can combine those two things. They're sitting in their control center, okay, and in their ADMS or whatever system they use. No, they can see visually, okay, yes, my control system automation system is telling me that this transformer is getting overloaded, but I have a visual confirmation also. And that is the power utilities get from the data, okay? And I think we can have a difference of opinion. I think we don't need to bring all the data to the control center. We bring the decision to the control center and amount of data needed for regulatory purposes or additional analytics.
Yeah, thank you, Prithpal. And so there's a lot happening in the political arena too, about how we protect our assets, right? They are critical assets. We saw the domino effect from the Colonial Pipeline attack, and that was not even an attack on an OT system, right? It was an adjacent system where there was essentially an enterprise system that the OT system depended on to operate. And so as a result, we've seen that national security memorandum. And so, Dave, what are you seeing as far as how that's affecting the administration of cybersecurity programs? Keeping in mind we already have NERC, but there's a lot of the electrical grid that isn't a NERC registered asset. And so how is that affecting the administration of these programs?
Yeah, well, I think it's a good reminder that compliance in general is a great foundation to build upon. But like you said, there's coverage gaps. Many frameworks only look at certain types of devices, and I don't want to say it becomes a game to make sure that you have as least number involved as possible, but there is really some start and an end that can create some blind spots or whatnot if you adhere and purely look at it from a compliance perspective. So it's good that we have these mandates. It brings awareness to the industry, but we also have to acknowledge that typically they're reactive. Something has happened, and now we have a mandate, right? And so that's why I like to really, when I'm talking about this, is really look at compliance as a great foundation, but then looking at how you mature your cybersecurity program on top of that. How do you really build in effective security? Because compliance is only a piece of that. So as you focus on building your program, how do you take it to a mature level that has repeatable and measurable processes that look across the whole enterprise? Because we're in a day and age where devices, processes, people aren't as isolated as they once were in utility. So we can't really expect to create these same islands of compliance and have that effectively take care of us from a security perspective, right? And so I think it really leads to a cultural change and an approach that needs to be intentional, and knowing that compliance is always going to update. It's always going to be there. You're going to have to pass an audit. But and we don't need to treat those as necessary evils or anything like that. It's the foundation, and we build on top of it. And so, again, it really comes down to, from my perspective, people, process, technology, and how you build all those together, and have it informed by whatever regulatory requirements you have, and things like that. So.
Thank you. And, I think as a result of this, we're starting to see organizations care a lot more about cybersecurity, that maybe weren't bound by NERC CIP. There's a lot of things in NERC CIP, a lot of regulations in NERC CIP, and a lot of organizations use it as a good foundation. I think there's also a lot of disagreement about maybe what should and shouldn't be within the standard. And so, Landon, I'm curious, how has this affected your non-NERC registered assets? Do you work with neighboring utilities that maybe are looking to start up their cybersecurity program, that are looking to you as a reference? And what are some of the things that they're doing? What is the first steps to take when you're looking at essentially establishing a cybersecurity program for something that maybe hasn't needed one, but really does now?
All right, first, if NERC CIP is your only cybersecurity program, then you've really missed the mark in the intent of the program, right? I believe NERC CIP, like you mentioned, is a great foundation. It was a catalyst for us to look at our security programs much closer and improve our overall security posture. The mandate frankly should not have a whole lot of effect on you, in my opinion.
Okay.
When CISA cries out, shields up, you shouldn't have to change much because it's already a way of your way of life.
Should already be up, right?
Yeah, absolutely. It should be a part of your culture. You are a target. You are a utility. You are a target. That's all there is to it. So with that said, the NSM shouldn't be a wake-up call. Finally, it should be, hey, just a reminder. Keep working hard. Keep your stuff secure. Keep doing what you do well. Hopefully, though, and yes, you asked if I do anything with neighboring utilities. There are several industry groups out there. I'm a part of the Utility Telecom Council, UTC, and we have a lot of things going on. The TV PPA, I get to speak at one of those things actually here in the next few months about getting a cybersecurity program up and running. And so, yes, it's very important. It's very important that the C-suite understands how much exposure you really do have as a distribution utility, how vulnerable you are if you don't have a good cybersecurity program, so that they can invest attention, money, and manpower, frankly, dedicated to the OT departments. So IT is great. IT, for some reason, gets a lot of security money. A lot of times OT has gotten swept over to the side. You little engineers and people, y'all just do your little thing over there.
We
really
don't understand what you do, so.
Right. You've got weird pieces of strange equipment. Y'all just keep that running over there. And so now that we are moving in a more integrated IT-ish, OT-ish technology market, really the C-suite has to be understanding of that. You need to be able to get in front of your leaders and make sure they are aware that you do have a critical system that has to be maintained and secured, so that you do have the proper dedication towards it.
Great. Thank you.
Landon, you are right here. I think the OT systems are going to look more and more like IT systems, and they need the investment to build all the capabilities and tools.
Thank you. And so we do have some good questions coming from the audience. One comes from Hugo. What is your opinion about the gap between the personnel and the technologies used in IT and OT, and how does that translate into security problems due to that lack of integration? A follow-up is, how do you think that in the future this gap can be reduced, and what technologies can be used? one of the things that I have seen as far as integration is really the use of APIs or similar types of integrations. Prithpal, what are you seeing? And just keep in mind that we are nearing the end of our time. What type of technologies are you seeing to really integrate these systems within utilities?
Yeah, I think the biggest technology we need to embrace is the software-defined infrastructure. Utilities use that infrastructure in their data centers, and they need to expand that into their substations and where else it is applicable. I think that is the key. Once we push that infrastructure, then we're going to have this IT, OT merging together, and the cross-pollination of expertise and skills will happen.
Thank you. And we have another question from Ahmed. Says, I want to ask about the challenges that come from field service engineers and how they interact with OT networks. I'm guessing this relates to technician laptops and how they can be a threat, essentially bypassing some of our network security. And so, Dave, 1 minute, how does this looked at within utilities, and what can be done to solve it?
It's a challenge because typically we have some legacy approaches, jump servers, what have you, to be able to facilitate it. So again, I think from my experience, what I looked at was how do we adopt, and this is, even to relate it to the first question, how do we bring some of the best practice from IT and add an OT context to it? So how can we bring in concepts like IAM and device profiling? And again, these several layers that typically make up zero trust principles to increase the security on that device. So even it can gain even the first level of ingress to get to a jump server, right? I mean, I think you gotta look at it from that perspective, is that jump server or not, or whatever topology you have, that device is still a device that could potentially become compromised. So again, adopt bring best practices from IT. It's not easy. We have a lot of legacy software and whatnot that would be on these devices, but the more knowledge share that can happen there, testing, labs, all those sorts of things. I'm answering some of the other questions too, but contribute to really better securing these OT environments as they change and as they become much more dynamic.
Thank you. And so we've reached the end of our time today. There's a survey at the end of this webinar, and we ask that you take the time to give us your feedback. That feedback helps us provide better webinars for you in the future. We have 1 more minute left. There's another question. How can you better understand and defend against chained risk? So they're using an example of a remote device becoming compromised, and then using that to gain access to other systems on the same level. Landon, I guess 30 seconds left. How can we defend against chained attacks such as that? The answer that comes to my mind is tighter segmentation. I'm curious what you're doing to address that. Okay.
Better data, better monitoring, better segmentation.
Awesome. Thank you.
Take that, less than 30 seconds.
That was great. And so thank you for all who attended. I hope you enjoyed the webinar. And once again, please fill out that survey. That really helps us make quality programs. Thank you.
Great. Thank you for hosting it.